If we go by definition, ADFS works on claims-based identity model. ADFS is a component of Windows Server operating system that provides users with single sign-on access to the systems and the applications. Those are located across organizational boundaries. Let's consider a couple of examples and things will be more clear. Let's assume we have two organizations, Organization 1 and Organization 2. Organization 1 wants to access an application that is hosted in Organization 2. Now, to achieve this, both organizations need to create a trust so that they can share their resources with each other. But this can lead to a security risk because both organizations will be able to access all of their resources. And moreover, in order to create a trust, both organizations need to open certain port numbers. For example, 389, 443, 89, and 636. Now, this is where ADFS comes in the picture. In ADFS, we create a federation trust with a particular application. And this way, the users from one organization will be able to access only the application that they are authorized to. And this trust requires only port 443 to be opened. Let's consider one more example and let's understand why do we need ADFS. When an Active Directory user account wants to access certain applications, Active Directory will generate a Kerberos ticket once the user has been authenticated. And this Kerberos ticket will be sent to the applications that this user is trying to access. Now, one thing to note here is that Kerberos ticket will always contain same set of attributes. A Kerberos ticket contains user account SID, group SID, and authentication timestamp. Now, in this example, a user is trying to access two different applications. When this user will be authenticated, Active Directory will generate two Kerberos tickets and will send these tickets to both the applications. And both Kerberos tickets will have same set of attributes. So that means it doesn't matter what sort of applications user is trying to access. Same set of Kerberos tickets will be sent to the applications. But the things will change when applications need a different set of attributes for the authentication purpose. Let's say if application 1 needs department attribute and application 2 needs email address attribute for authentication. They do not need group SID or account SID attributes. So this is where ADFS come in the picture. Every user in Active Directory has certain attributes. For example, email address, department, user principal name, or contact number. All these attributes are called claims in ADFS. In ADFS, when a user will try to access certain applications, those applications will contact ADFS server. Then ADFS server will contact Active Directory to get the user authenticated. And once the user is authenticated, ADFS will send a token to the applications. But ADFS has the ability to customize the token as per the application's requirement. If application 1 needs a token on the basis of department attribute, ADFS server will construct a token on the basis of department attribute and will send this token to the application. In the same way, if another application's requirement is that the user should be authenticated on the basis of email address attribute, ADFS will construct another token including email address of the user and will send this token to the application. So this is one of the reasons why do we need ADFS. ADFS has the ability to customize the response as per the application's requirement. If an application's requirement is that once user is authenticated, I need email address attribute in the token to validate that user. So ADFS will construct a token. It will include email address attribute within the token and will send this token to the application. Application provider will validate the token and will provide access to the user. And this is called claims-based identity model or claims-based access control authorization model. Now, if we compare Active Directory with ADFS, so what we can understand, the acknowledgement that Active Directory issues after the authentication is called ticket, and the acknowledgement that is shared by ADFS is called token. Kerberos tickets that are issued by Active Directory cannot be customized, but ADFS token can be customized as per the application requirement. In Active Directory, applications directly contact Active Directory for authentication. But in case of ADFS, applications contact ADFS server because ADFS is placed between the application and Active Directory. So applications will contact ADFS and ADFS will contact Active Directory for authentication. Now let's understand what is a federation trust. Let's consider one example. Let's say you are going to board a plane. When you enter to the main gate of the airport, you need to show your ID proof. An ID proof can be your driving license, it can be a passport, or even Aadhaar card. Once you show your ID proof, you go to the ticket counter from where you get the boarding pass. And once you get the boarding pass, you will go to the boarding gate and will board the flight. Now, the question arises, why airport authority should let you enter inside the airport on the basis of your ID proof? Why should they trust your driving license or your passport? You got the driving license from the Department of Public Safety. You show your driving license to the security guard and you get access to the airport. Because there is a trust between the Department of Public Safety and the airport. Because of this trust, you can get access to the airport premises by showing your ID proof. In ADFS, when a user tries to access an application that is hosted in another organization, he is asked to prove his identity. User will go to his identity provider. Identity provider will issue a token to the user. User will provide that token to the resource provider. Resource provider will issue another token to the user. Then user will provide that token to the application and user will get access to the application. But again, question arises, why would resource provider should trust this user? Why resource provider organization should trust the token that is sent from the identity provider? Because there is a trust between two organizations. One important thing that we need to notice in this example is that entire communication that is being done among user, identity provider, and the resource provider is handled by the user itself. In ADFS, entire communication is handled by the client machine. Identity provider do not directly contact resource provider. The client machine will contact identity provider for authentication. Client machine will forward the token to the resource provider. Then client machine will receive token from the resource provider and will forward that token to the application. So we are reducing the load on the server. Entire load is taken by the client machine. Now let's understand few terms that I will be using throughout this series. What is claim? A claim is a piece of identity information. It could be display name, email address, or department. All these Active Directory attributes are called claims in ADFS. Security Token Service or STS issues the tokens to the authenticated users. Its job is to issue security tokens to the applications. For example, when you log into portal.office.com, you are redirected to login.microsoftonline.com, which is the security token service for portal.office.com. ADFS is also a security token service or STS. Claims provider is a service that issues claims during the sign-in process. An example of claims provider is Active Directory. Identity provider provides the single sign-on functionality between an organization and the applications. An example of identity provider is ADFS. Relying party is the one who is hosting the application. Relying party consumes the tokens those are issued by ADFS server. Standalone federation server is a type of deployment where you install only one ADFS server in your environment. Standalone federation server was available in Windows Server 2008, 2008 R2, and in Windows Server 2012. This concept was discontinued in Windows Server 2012 R2. When we talk about standalone federation server, there is only one ADFS server within your environment. You cannot add another ADFS server in your environment if you choose standalone federation server deployment option. Let's say you had a small organization and that time you installed ADFS using standalone federation service option. But now your organization is expanding day by day, so you might need to add another ADFS server in your environment. But with standalone federation server, this is not possible. If you have selected standalone federation server, you cannot add more ADFS servers in your farm. And if this ADFS server goes down, you do not have a backup. That is why this type of deployment was discontinued in Windows Server 2012 R2. Next type of deployment that we are going to talk about is Farm Federation Service using Windows Internal Database or WID. Farm is basically it's a boundary in which you have deployed multiple ADFS servers. This type of deployment is supported from Windows Server 2008 and it is still being supported. When we install ADFS server role, we can choose if we want to install ADFS with default method or we want to install it using SQL instance. If we select default method, in that case, Windows Internal Database or WID gets installed with ADFS server. This database is called ADFS Configuration Database. ADFS use this database to store the configuration related data. For example, if you create a relying party trust or you make any changes within the ADFS server, all these changes or all this configuration will be stored within this database. Now the first ADFS server that you install within your farm is called primary ADFS server. And the database that is installed for the primary ADFS server holds the read and write copy of the database. If you add another ADFS server within your farm, that ADFS server will be named as secondary ADFS server. And this server will hold a read-only copy of the database. In this type of deployment, if you have to make any changes, you will have to log in to the primary ADFS server because only primary ADFS server holds a read and write copy of the database. So all the changes will be done only in primary ADFS server and these changes will be replicated to all secondary ADFS server. The secondary ADFS servers connect to the primary ADFS server every 5 minutes. They replicate the copy of the ADFS configuration database every 5 minutes. Every 5 minutes, Secondary ADFS server will connect to the primary ADFS server, and they will query for the recent changes. Those are done within the primary ADFS server. In Farm Federation service with VID, if primary ADFS server goes down, you can promote the secondary ADFS server as primary. This type of deployment has some advantages and disadvantages. Farm Federation service with VID is easy to deploy. We can install multiple ADFS servers within the farm. We can deploy load balancing servers within the ADFS servers to equally distribute the traffic. And if one ADFS goes down, we can make other server as primary. And this type of deployment is easy to expand. That means we can add more servers to our farm. But this type of deployment supports only 5 ADFS servers. We cannot install more than 5 ADFS servers within the farm if we have selected Farm Federation using Windows Internal Database or WID. The other disadvantage of this type of deployment is that we can create only 100 relying party trust within the ADFS server. If we create more than 100 relying party trust, it will not accept it. In Farm Federation service using WID, any changes that we need to do it on primary ADFS server. We cannot make any changes on the secondary ADFS server because these servers hold a read-only copy of the database. The third type of deployment for ADFS is Farm Federation service using SQL. This type of deployment is also supported in all versions of Windows Server. In this type of deployment, every ADFS server within the farm is called primary ADFS server. And every ADFS server uses the same database that holds read and write copy of ADFS database. That means if you want to make any changes within the ADFS configuration, you can log into any ADFS server within the farm and you can make the changes. And those changes will be replicated to all the ADFS servers. So in ADFS with SQL deployment, there is no concept of secondary ADFS server. All ADFS servers will act as primary ADFS servers. And if you want to make any changes within the ADFS configuration, you can log into any ADFS server and you can make those changes. If we talk about advantages of Farm Federation using SQL, this type of deployment supports multiple ADFS servers. Fault tolerance is possible. If one ADFS server goes down, other ADFS server within the farm will take over. This type of deployment is easily scalable and changes can be made on any ADFS server because all ADFS servers hold read and write copy of the database. But this type of deployment is more complex to maintain. You can add multiple ADFS servers in your farm, but when it comes to maintain them or troubleshoot them, it can be a complex task. Every ADFS server is dependent on a single SQL server. So if SQL server goes down, every ADFS server will be affected. So basis on your business requirement, you can decide if you want to install ADFS using Windows Internal Database, which is default installation, or you want to install it using SQL Server. But the recommended deployment is Farm Federation with Windows Internal Database. Now let's move to the next topic, that is certificate requirements for ADFS. In ADFS, you will find three types of certificates: Service Communication Certificate, Token Signing Certificate, and Token Decrypting Certificate. For this particular session, I will be discussing only Service Communication Certificate. I will be conducting a separate session that will be dedicated to the certificates in ADFS, and all types of certificates will be explained in detail. So, what is a Service Communication Certificate? Service Communication Certificate is used for the secure communication between ADFS server and the application. It creates an SSL connection between the ADFS and the application. Service Communication Certificate should be a third-party certificate. If you are deploying a test lab for ADFS, then you can use an SSL certificate that is issued from internal certification authority. But in your production environment, always use SSL certificate that is issued by a third-party certificate provider. The subject name of the certificate should match the Federation Service identifier of your ADFS server. You can use either wildcard or SAN certificate. Both type of certificates are supported. Same service communication certificate can be used on all ADFS servers and in proxy servers. So if you are planning to deploy multiple ADFS servers or you want to use ADFS proxy server, you can use same certificate on all the servers. Let's take a look on few basic prerequisites that needs to be met before we install ADFS service. An SSL certificate is required for ADFS. The machine on which we want to install ADFS must be a domain joined machine. We would require enterprise admin credentials, and if you want to add Office 365 as a relying party trust, in that case, you need to deploy Azure AD Connect, and user accounts should be synchronized to Office 365. So first, let me show you how to create an SSL certificate from internal certificate authority. This is the domain controller and I already have installed certification authority role on this particular server. So let's go to certification authority. If you do not have this role installed, so before you create a certificate, you need to install certification authority role on that particular server. So right click on certificate template and click manage. First, we are going to create a certificate template, and on the basis of that certificate template, we will import an SSL certificate. On the next screen, you will right click computer and then click duplicate template. Now on this particular wizard, we will make certain changes. On the general tab, you can give any name for this particular certificate template, and you need to check this option that says publish certificate in Active Directory. On request handling tab, check the option that says allow private key to be exported. After that, in security tab, you need to add the machine or the server on which you are going to install ADFS role. So click add and go to object types and select computers so that you can search your computers here. Then type the host name of the machine on which you need this certificate. Then click check names, select the machine and then click OK. Allow full control, and the last change that you need to do is under subject name tab where it says subject name format, you need to select common name and then click apply and then click OK. So this will create a certificate template. Now, once it is done, go back to the certification authority, right click and then click new and click certificate template to issue. Here you will see the certificate template that you just created. Select that and press OK. That's it. Now let's go to ADFS machine, or on the machine you want to install ADFS role. On this particular server, we will go to MMC. So this is the server where I'm going to install ADFS. And let me show you. This is a domain joined machine. You can see this particular machine is joined with Office 365 concepts.com. That is my Active Directory domain. And this is Windows Server 2016 data center server. So I'm going to install ADFS on this particular server. So now let's create SSL certificate. Go to MMC, file, add, remove snap-in, Select certificates, click add. Make sure you are selecting computer account here because we are going to create a certificate for the computer account, not for the user account. This will be for computer account. Select computer account, go next, finish, click OK. Now expand certificates, right click personal and go to all tasks and click request new certificate. Now we are going to request a new certificate from the certification authority. So click on this, go next, click next, and here you will see the certificate template that you just created. Click enroll. That's it. Click finish. Now we have enrolled this certificate and we can use this certificate. Let me show you the certificate first. So this is the certificate that we are going to use for ADFS installation. ADFS server will use this certificate as a service communication certificate. If you want to check the details, this certificate is issued to adfs.office365concepts.com, which will be my ADFS server. These are the details. If you want to check the thumbprint, this is the thumbprint of this certificate. You can check the date of issue and date of expiry, valid from this date and valid till this date. So this is the certificate that we are going to use. Now let's install ADFS role. We will go to Server Manager, then click Add Roles and Features. Click Next, Next, and Next. Here we will select Active Directory Federation Services. Then click Next. No changes here. Next, Next, and Install. So this will install Active Directory Federation Services role. Once this role is installed, we will configure this server as a federation server. For example, when you install Active Directory, first you install Active Directory role. Once that role is installed, you promote that particular machine as a domain controller. So in the same way, first we will install this role and here it will ask you configure the federation service on this server. So we will click on this role, we will click on this option. When you will click on this option, the first thing that this wizard will ask you, it will ask you, is this the first ADFS server that you are going to install within your farm? Or you want to add an ADFS server within the existing farm? The first option is create the first federation server in a federation server farm. And if you already have a couple of ADFS servers and you are trying to add another ADFS server, then you will select the second option. So this is the first ADFS server. I'll select the first option and then I'll go next. Here you will type the credentials of the enterprise admin. So for my case, it is this one. Press OK, go next. Okay, now under SSL certificate, you will select the certificate that you just created. Federation service name is the ADFS identifier name for your organization, for the ADFS server that you're going to create. I'll show you from where you can check this federation service name. Federation service display name is, if you are familiar with ADFS working, what happens if any application which is integrated with ADFS, when users try to log into that application, those users are redirected to ADFS web page. Like you enter portal.office.com, then you are redirected to your ADFS server. So when you are redirected, you see ADFS web page where you enter your password. At the top of that page, you see certain like your organization name or something that is defined by the admin. So for example, if I mention here ADFS Office 365 concepts. So when my user will be redirected to my ADFS server, he will see ADFS Office 365 concepts on that particular page. I'll show you practically this as well and things will be more clear. So this is Federation Service display name. Go next. Now here you need to type the credentials of a user account. This account needs not to be an admin. It can be a simple user account, and this account will be used by Active Directory Federation services. So I already have one account, and let me use that one. And let's type the password. Go next. Now on this particular screen, it is asking you what type of deployment method you want to use for your ADFS configuration. You want to install ADFS using Windows Internal Database, that is WID, or you want to install ADFS using a SQL Server. If you have a SQL Server, you can type those details here. If you do not have SQL Server in your environment, you can select the first option and Windows Internal Database will be installed along with the ADFS server. So let's select the first option because I do not have SQL Server. Go next. Now this wizard will check the prerequisites. If all the prerequisites are passed, you can simply click on configure and it will install ADFS services on this particular server. Here it says all prerequisite checks passed successfully. Click configure to begin installation. Click configure. Now this wizard is going to take 1 or 2 minutes and it will install ADFS services on this particular server. So once it is installed, after that we will take a look how ADFS management console look like, from where you can manage all the configuration of ADFS server. And after that, I'll show you how to add Office 365 as a relying party with ADFS, or how to federate your Office 365 domain with ADFS. And then I'll show you how a user experience will look like when he will try to log in to portal.office.com. So ADFS server is configured. Let's close this, close this. Now to access ADFS management console, you will go to server manager, tools, and then click ADFS management. Let me close server manager. Okay, so this is ADFS management console. This is the place, or this is the interface from where you will manage all the configuration of this ADFS server. You can check services, you can check certificates, claim descriptions, endpoints. You can create access control policies, relying party trust, claim provider trust. We are going to discuss all these options in upcoming videos. I just wanted to show you how ADFS management console look like. Now, ADFS is configured. Our ADFS server is ready. But post configuration, we want to check if ADFS is configured properly or not, whether ADFS redirection or authentication is working or not. So to check that, there is a tool which is called IDP initiated sign-on page. If you want to access that particular tool or the link, you can run get hyphen ADFS properties pipefl and look for enable IDP. So this is the property. By default, IDP initiated sign-on page is disabled. Before you use IDP initiated sign-on page, you need to enable it. And you must be thinking what exactly IDP initiated sign-on page is. So IDP initiated sign-on page is, this is used to check if ADFS authentication or redirection is working properly or not. So first, let's enable it, and then I'll show you how you can use it. So it will be enable IDP tab and $true. So now it is enabled. Now let me show you how to use IDP initiated sign-on page. Let's go to ADFS endpoint. Let me try this way. And look for an endpoint which ends with ADFS/ls. Copy this endpoint. We will talk about endpoints as well later in one of the next videos. So go to browser, paste the endpoint URL that you just copied, and at the end type IDP initiated sign-on page.aspx. Press enter. Now this particular link will redirect you to your ADFS server. Now, if you remember, while we were installing ADFS, we were asked for Federation Service display name, and I typed ADFS Office 365 concepts. So whenever my users will be redirected to my ADFS server, they will see this text. So this is the Federation Service display name. And there was one more thing that I can show you. Let's go to Federation Service properties. And this is your Federation identifier, which is adfs.office365concepts.com, which was visible as Federation Service name just below SSL certificate. Now let's go back to the browser and click sign in. Here you can type the credentials of your user. Let's type this one, type password and press enter. So here you can see you are signed in. So that means ADFS redirection and authentication is working properly. Click sign out, close the browser. Now the next thing that I want to show you is how to federate your domain with ADFS. Now let's go to Azure Active Directory PowerShell and let's connect to MSOL service, because we are going to run commands for Office 365 domain. So those commands start with MSOL. So that is the reason we are going to connect with MSOL service. So enter credentials of your global admin for your Office 365 tenant. No, I do not want to create the account. Let me try again. So now I'm connected to MSOL service, and the first command that we need to use is set-msol adfs context -computer, and here we will type the FQDN of this particular server. It will ask you for the credentials of the admin who is logged in currently. So I'm logged in with this one. Now the next command is convert-msol domain to federated-domain name, and here you will type the name of the domain that you want to federate with Office 365. This domain is already federated with my ADFS server. If I'll run this command again, it will say domain is already federated. So here we can see this domain already uses single sign-on. And the third command that you need to run is update-msol federated domain name and your domain name. Press enter. So this command is basically used to update the settings between the ADFS server and in Microsoft Online. There is a very famous example of authentication protocol that you follow each time when you visit an airport. If you want to board a plane, you can't simply walk up to the boarding gate and you just can't show your driving license or the passport and get to the plane. Instead of this, what you do, you first show your driving license or any ID proof to the security agent on the main gate of the airport. Then you go to the ticket counter. From ticket counter, you collect your boarding pass. Once you have the boarding pass, you go to the boarding gate. You show your boarding pass to the boarding gate agent. After verifying your boarding pass, boarding gate agent lets you board the plane. Now, if you check the boarding pass, it includes the information that this boarding pass has been issued by an airline. It has your name, it has the information that you're allowed to board a particular flight. It has the information that you're going to board this flight at this particular time, and this will be your seat number. There are multiple ways to get a boarding pass. You can either collect it from the ticket counter, or you can book your flight online and you can print your boarding pass at home. The boarding gate agent doesn't care how the boarding pass was created. They don't care which issuer you used. As long as it is trusted by the airline, it is valid. They only care that it has authentic set of information that give you permission to get on the plane. Now, if we compare this example with ADFS, the bundle of information or the boarding pass is called security token in ADFS. Each security token is signed by the issuer who created it. Any claims-based application will consider a user to be authenticated if he presents a valid and a signed token that is issued by a trusted issuer. In this example, the boarding pass was issued by the airlines. That means airlines is the issuer. And you can compare airlines with ADFS because ADFS issues the security tokens to the applications. In this example, plane is the application. Plane doesn't care what sort of ID proof you are showing to the boarding gate agent, whether you have shown your driving license or you have shown your passport. But as long as you have a valid boarding pass, you can board the plane. In the same way, when an application connects to the ADFS server, the application doesn't care if the user was authenticated using NTLM or he was authenticated using Kerberos. Application doesn't care what sort of credentials that user presented for authentication. What sort of authentication method was used? Was it forms-based authentication, SSL, or it was integrated Windows authentication? As long as a valid security token that is signed by a trusted issuer is issued to the application, user can get access. When ADFS issues a token to an application, it signs the token using token signing certificate. The application that is integrated with ADFS also has your ADFS server's token signing certificate that is used by the application to decrypt the token. Now you must be thinking how application has access to this token signing certificate. So the answer is federation metadata. This is something that we will be discussing in one of the next videos, but for now just understand that application also has the token signing certificate of your ADFS server that is used to decrypt the token that is sent or that is issued from the ADFS server. A boarding pass contains some information like your name, flight name, your seat number, and the name of the airlines who has issued this boarding pass. A security token also contains similar information. It has the name of the issuer, that is Federation Identifier name of your ADFS server. It contains the name of the application to whom this token is issued. It has the details of the claims. It has the timestamp when this token was issued until what time this token is valid. And it includes token signing certificate that was used by the ADFS server to sign this token. There are multiple types of tokens. Those can be issued by the ADFS server and can be consumed by the application. If an application is using WS-Fed protocol, ADFS will send SAML1 token to the application and the format of the token will be XML. If an application supports SAML protocol, then SAML2 token will be sent to the application and the format of the token will be XML. If application supports OAuth protocol, then ADFS will send JOT token to the application and the format of the token will be JSON. And if application supports OpenID Connect protocol, then JOT token will be sent to the application and the format of the token will be JSON. So depending on the protocols that application supports, ADFS will construct the token and will send the token to the application. Now let me show you what sort of information a security token contains. This is a token that was issued for a user when he was trying to access portal.office.com. The first thing that you will see within the token is the time or date when this token was created. This token was created at this date, 8th of December 2021 at 10:30, and it is going to expire same day after 1 hour, 11:30. Next thing that you will see, the issuer name. Issuer of this token is my ADFS server and this is the ADFS Federation identifier name. If you go to Server Manager and if you go to ADFS Management Console, let's minimize or close Server Manager. Right click on ADFS and go to Edit Federation Service Properties. Here you see Federation Service Identifier, that is adfs.office365concepts.com/adfs/services/trust. Now go back to token and here you can see http adfs office365concepts.com/adfs/services/trust. So this is the ADFS Federation identifier who has issued this particular token. Next, you will see the name of the application who is going to consume this token. This token is issued for Office 365 Microsoft Online Service, and this is what you can see here. Next, you will see claims. Whenever a user is trying to access Office 365 application, in case of Office 365, two claims or two attributes are issued within the token. One is user principal name and the second one is immutable ID. This is the user principal name of the user who was trying to access portal.office.com, and this is the immutable ID of this particular user. So these are the two claims. Those are sent within the security token if the application that user is trying to access is portal.office.com. And after claims, you will see the token signing certificate. You will find the token signing certificate next to X509 certificate header. So if you want to check the certificate, copy this till here, not this one. Okay, I'll remove this next part. So go to Notepad, paste it here, and remove this one. Now save this file, and you will save this file with .cer extension. Close this and open this certificate. Let's close this as well. Okay, now go to details and go to thumbprint. So let's go to ADFS management console as well, and let's go to certificates, and let me double click on token signing certificate and go to details. Now here you see this thumbprint of the certificate starts with 8B and ends with AD, and same starts with 8B ends with AD. So this is the token signing certificate that is configured within your ADFS server. Whenever ADFS server will sign a token, it will use the token signing certificate. ADFS provides the logic to authenticate the users in several ways. ADFS can customize every security token as per the application requirement. ADFS server can accept the tokens those are issued from another ADFS server from another realm. This is called identity federation. A realm is basically it's a security domain or security boundary for your applications. In this example, these are two different realms. When an application contacts ADFS, ADFS reaches Active Directory to get the user authenticated. Once the user is authenticated, Active Directory returns certain claims to ADFS. Then ADFS constructs a token, it includes the claims within the token, and sends that token to the application. Application doesn't directly authenticate the user. It completely relies on the security token that is issued by the ADFS server. A claims-based application should know how to validate the incoming security token and how to read the claims those are inside the token. Each application is different and not all applications need the same set of claims. One application might need the email address of the user and other application might need department attribute. And ADFS has the ability to customize the security token as per the application requirement. If application 1 needs email address attribute, ADFS will construct a token. It will include email address attribute or claim within the token and will issue that token to the application. In the same way, it will construct another token. It will add department attribute within the token and will send this token to the application. So ADFS can customize the tokens as per the application's requirement. Now let's understand why you should choose claims-based identity. When we talk about Kerberos can't authenticate the users who are in different realm because the domain controller is guarded by the firewall. And if you are working externally, you are expected to use a virtual private network or VPN to access the corporate network. If you have internal application and you have Active Directory, you can use integrated Windows authentication to achieve many of the benefits those are provided by the claims. As long as your application can use integrated Windows authentication, you do not have to think more about the authentication. But claims were designed to provide the flexibility that other protocols may not provide. The standard protocols that exchange claims are specifically designed to cross boundaries. For example, security realms and firewalls. With claims, it's no longer the application's responsibility to authenticate the users. All your application needs is a security token from the issuer. And if you are upgrading the security of your infrastructure, this will not break your application or there is no need to reconfigure the application. Claims are issued by a claims provider. They are packaged into a security token and this security token is issued to the application. Here claims provider is Active Directory, and the service that issues the token is Security Token Service or STS, that is ADFS. There are many reasons why you might need something other than Windows authentication. You might have a web application that is used by the people who do not have accounts in your Windows domain, or your company has merged with another company and you are having trouble authenticating across two different Windows forests that do not have a trust relationship. These are a couple of scenarios where claims-based identity is the right option for you. An application can be a browser-based application, or it can be a rich client application, for example, Outlook client. That means a user can access this application using either a web browser or using Outlook client. And if this application is integrated with ADFS server, then ADFS server should be capable enough to receive all types of applications request. It should be able to receive the request from web-based applications and from rich client applications as well. But how ADFS server will identify that the request that he is getting is coming from a web-based application or it is a rich client application? ADFS identifies these type of requests with the help of endpoints. When we install ADFS, few endpoints are created automatically. You can access these endpoints either from ADFS Management Console or you can run get-adfs endpoint and this will list all of the endpoints of your ADFS server. These endpoints are responsible to receive certain types of requests. There are multiple endpoints in ADFS server, but for this particular session, we are going to talk about two important endpoints. The first endpoint that we're going to talk about is ADFS/ls and trust/MEX. ADFS/ls endpoint is responsible to receive requests from web-based applications. That means if user is trying to access a web-based application, that request will be processed by ADFS/ls endpoint. And if user is trying to access a rich client application, that request will be processed by trust/MEX endpoint. Here MEX stands for exchange metadata. And when a user tries to access a web-based application, this type of authentication is called passive authentication. And this type of authentication request is received by ADFS/ls endpoint. And when user tries to access an Outlook application, that type of authentication is called active authentication. And this type of authentication request is processed by trust/MEX endpoint. If you check these endpoints in your ADFS server, you can see that these endpoints are secured with HTTPS. That means any communication that is happening on this endpoint is secured. And these endpoints are secured with the service communication certificate of your ADFS server. I will show you this practically as well. The next part that you see in this endpoint is the Federation service name of your ADFS server. And next to the Federation service name is the URL of the endpoint that is responsible to receive certain requests. First, let me show you how you can access or manage the endpoints from ADFS Management Console. If you want to open ADFS Management Console, you can go to Server Manager, go to Tools, and then click ADFS Management. From ADFS Management Console, go to Service, and then go to Endpoints. On this particular page, you will see the list of all the endpoints. Those are available within your ADFS server. Now, the first thing that you will see is enabled. If you see yes next to any endpoint under enabled, if it says yes, that means this particular endpoint is enabled on this ADFS server. Now, what does it mean? This ADFS endpoint is ADFS/ls. That means this endpoint is responsible to receive request from the web applications. Now, if I disable this endpoint, now this endpoint will not be able to receive any request from a web-based application. Whenever you enable or disable any endpoint, you need to restart ADFS service. For this, you will go to services.msc, and the first service that you see here, Active Directory Federation Services, you just need to restart this service so that these changes can be replicated on the Windows, your ADFS server. Moreover, if you have multiple ADFS servers within your farm, let's say you have 5 ADFS servers in your farm and you are enabling or disabling an endpoint, in that case, you need to restart this service on all of the ADFS servers. Next is proxy enabled. We will talk about proxy server later, but for your understanding for this particular video, proxy server or ADFS proxy server is which is responsible to receive requests. Those are coming from the external network. We do not publish ADFS server to the internet. So that means any user who is trying to access an application from external network, his request will not reach to our ADFS server. That is the reason we deploy ADFS proxy server. So proxy server will receive the request, then it will forward that request to the ADFS server. So if endpoint is not enabled on proxy server, that means that request will not reach to the proxy server. Now here you can see this endpoint is enabled in ADFS server, but this endpoint is not enabled in proxy server. So if a user will try to access a federated application from external network, then he will not be able to reach to that application. So what you need to do to enable this endpoint on proxy server, you will click on enable on proxy and you need to restart this ADFS service and this endpoint will be enabled on the proxy server as well. In the same way, if you want to enable this endpoint on ADFS server or on proxy server, you can click on enable and these endpoints will be enabled. All these endpoints are secured with the service communication certificate of your ADFS server. Let's go to PowerShell and let's run get-adfs endpoint. And let's look for the endpoints only. For example, if I copy this endpoint and let's go to browser, paste the endpoint here, and then go to certificate. Let's go to details and go to thumbprint. The thumbprint of this certificate starts with 69, ends with EF. Now let's go to ADFS Management Console and go to certificates. Double click on Service Communication Certificate. Go to details, go to thumbprint, and here you can see starts with 69, ends with EF. So this service communication certificate is used for securing the endpoints on your ADFS server. Now, if you want to access endpoints from PowerShell, you can run get-adfs endpoint, press enter, and it will list all of the endpoints within your ADFS server. Now let's say you want to enable or disable a particular endpoint, or let's say this endpoint is disabled, so let's enable it. From PowerShell also you can enable the endpoint on the ADFS server, and you can enable it on the proxy as well. So let's say you want to enable this particular endpoint. Copy this endpoint, and the command to enable ADFS endpoint is enable-ADFS endpoint hyphen target full URL, and then type the URL or the endpoint that you just copied or you want to modify. Press enter. So when you will enable or disable any endpoint from PowerShell as well, you need to restart ADFS service. And after that, this particular endpoint will be replicated on the ADFS server. If you want to disable this endpoint, you can run disable-ADFS endpoint hyphen target full URL and paste the endpoint. Press enter. Again, you need to restart the service, and then this service will be, or the endpoint will be disabled. If you want to enable a particular endpoint on proxy server, for that command is set-ADFS endpoint hyphen target full URL, and let's say we want to enable this particular endpoint. Paste the endpoint and then type hyphen proxy and give it a value $true because we are going to enable it. Press enter. Again, you need to restart ADFS service, and let's verify. So here you can see this particular endpoint is enabled on the proxy server as well. If we go by definition, relying party trust is a term that is used to identify which applications are authorized to communicate with ADFS server. Let's consider one example and let's understand what does it mean. Let's say a user is trying to access an application. This application is integrated with ADFS server. Now this application will reach to an endpoint of this ADFS server to get the security token. ADFS will construct a token, will add claims within the token, and will send this token to the application. This is what usually happens when a user tries to access a federated application. But the question is how ADFS server will identify that the request that is coming from this application is a valid request or not. How ADFS server will identify whether this request should be entertained or not, or how ADFS server will know that I have to issue a security token to this particular application. So there has to be something so that ADFS server can trust this application. There has to be a trust between ADFS and application so that ADFS can accept the request from the application and it can issue a token to that particular application. And this trust is called relying party trust. When you integrate an application with your ADFS server, it creates a relying party trust for that particular application within your ADFS server. With the help of relying party trust, ADFS will identify that the request that is coming from an application is a valid request, and I have to issue a security token to this application. A relying party trust contains the information about the application name, the protocols that this application will support, and what sort of claims this application needs within the security token. Without a relying party trust, an application cannot communicate with ADFS server. So relying party trust is a communication channel between ADFS server and the application. And the organization that hosts this application is called relying party. Now let me show you practically how we can create a relying party trust. You can create relying party trust either from ADFS management console or you can use PowerShell. If you want to use PowerShell, then you can run command add-ADFS relying party trust. But if you want to do it from ADFS management console, then you will go to relying party trust and then you will click add relying party trust. On the first screen of this wizard, it will ask you the application that you're going to integrate with this ADFS server, whether that application is a claims aware application or it is a non-claims aware application. ADFS supports only claims aware applications because ADFS works on claims based identity model. So we will select claims aware and then we will click start. Now, before you integrate an application with your ADFS server, you need certain information for that application. Information like the URL of that application. Because when ADFS will issue a token to the application, ADFS needs a URL where it can issue that security token. Second, you need the information of the protocols. What sort of protocols are supported by the application, whether it is WS-Fed or it is SAML protocol. And third, you need the information of the claims. What sort of claims this application need within the security token from the ADFS server. So the application vendor can give you that information in multiple ways. He can give you an online link, or he can give you a file which is located somewhere on the network. So if you have online URL or a file that is located on the network, you can select the first option. And if you have a URL, you can simply type the URL here, for example, like this, and you can click next. This will create a relying party trust automatically based on the information that is available within this link. If you have the file on the network, you can specify the path of that file. And let's say you have XML file. The vendor of application has provided you federation metadata of the application in XML file. So you will click on second option and then you will click browse. You will select the file, click open, and this will create relying party trust. Now let's say you do not have online URL or you don't have a file on the network or you do not have XML file of the federation metadata of the application. Now in that case, you need to select the third option, that is enter data about the relying party manually. Click next. Here you can give it a name, for example, test relying party trust, and then click next. Here it will ask you for the token encryption certificate. If you have the certificate, you can browse to the certificate or you can skip this. Then click next. Now here it will ask you what sort of protocol application supports. Is it WS-Fed or SAML? Which protocol is supported? So based on the selection, you can select, based on the requirement, you can select the option. And here you need to mention the URL of the application. For example, like this. Then click next. So it has to be HTTPS. Click next. Here you have already selected. If this is not the URL of the application, you can add a new one. For example, like this, abc.application.com. Click add, and this will be added, and then click next. On this screen, it will give you an option that when users will try to access this particular application, do you want them to be prompted for MFA? If you select permit everyone, then the users will not get MFA prompt. If you select this option, permit everyone and require MFA, in that case, when users will try to access this application, they will be prompted for MFA. Same way, if you want to enable MFA for specific group, you can select this option. If you want that when a user is trying to access this application from external network, only in that case, those users will be prompted for MFA. So you can select this option. Or basis on your requirement, you can select any other option. So once you have made the changes here, click next. You can review the changes under this and then click next and then click close. So this relying party trust is created. That means this abc.application.com application can connect to this ADFS server. And this ADFS server can send security token to this application as well. However, there is no claim configured within this relying party trust. If you go to claim issuance policy, there is no claim rule defined. Claim issuance policy decides what sort of claims ADFS server will send to the application within this security token. If there is no claim, in that case, authentication will fail. So let's consider one small example to understand what exactly claim issuance policy is. When we create a user account in Active Directory, few attributes are created automatically. For example, name, phone number, department, or email address. In Active Directory, these are called attributes. And in ADFS, all these attributes are called claims. Now let's assume this user wants to access an application. So this application will reach to an endpoint of the ADFS server and will ask for a security token along with email address attribute of the user. ADFS will contact Active Directory to get the authentication done for this user, and ADFS will ask Active Directory to issue email address attribute of this user once this user is authenticated. So once authentication is done, Active Directory will return the claim to the ADFS server. Then ADFS server will construct a token. It will add the claim within the token and will send this token to the application. Now the rule that decides what attribute ADFS will ask Active Directory to issue and what attribute or claim ADFS will send to the application is decided by claim issuance policy. So claim issuance policy is a set of rules that decide which claim ADFS server will send to the application within the token. Claims X-ray tool is an online tool or online application that can be used to debug and troubleshoot problems with ADFS claims issuance. This is a web-based application. When you use this application interacts with your ADFS server, and then it checks if your ADFS server is issuing the security token or not. It checks if the authentication is working or not. So as I said, this is a web-based application and it interacts with your ADFS server. So that means there has to be a relying party trust for this particular application within your ADFS server. Because if there is no relying party trust and if you will test authentication using Claims X-ray tool, this tool will not be able to interact with your ADFS server because ADFS server do not entertain any request when there is no relying party trust for that particular application. Now, if we go to, let's try to test authentication. So as we can see, I do not have a relying party trust for Claims X-ray tool. This is the only relying party trust that is available and that is for Office 365. So now if I test authentication using this tool, this will fail. So as I said, this is a web application, and when you use this application interacts with your ADFS server. It communicates with your ADFS server. So in order to communicate with the ADFS server, this tool should have a relying party trust in your ADFS server. Because if there is no relying party trust in ADFS server, that application cannot communicate with the ADFS server, because ADFS server will not entertain that request. So to create relying party trust, there is a script that is available. You will go to relying party trust management and then you will click download. Make sure you are downloading this script on the ADFS server. So once this script is downloaded, you will go to PowerShell and let's go to this location where this script is downloaded. Copy the path, go to PowerShell and go to this path in PowerShell. Okay, now we will run this script, which is this one, claims x-ray manager.ps1. Press enter. Just follow the instructions and go with default settings. You do not have to make any changes. So operation is completed and let's close this and let's go to relying party trust. Click refresh and here you can see claims x-ray relying party trust is created now. So now this application can interact with the ADFS server. Now how you are going to test the authentication? You will go to next. Now you will see this particular page. Here you need to add the federation name of your ADFS server. You can find this name by right clicking on ADFS and then go to edit federation service properties. The federation service name that you see here, for my case, it is adfs.office365concepts.com. So copy the name that you see under federation service name, go to claims x-ray tool and paste it here. Authentication types are what sort of authentication you want to test with your ADFS server. You want to use forms based, Windows integrated authentication, certificate based or multi-factor authentication. Let's try with forms based authentication. Token request is what sort of token you want to request from ADFS, OAuth, SAML or WS Federation. Let's go with WS Federation default settings and then click force fresh authentication and click test authentication. Now you can see I am redirected to ADFS and I didn't get the error because now I have relying party trust for this particular application. So now this application can interact with my ADFS server and ADFS server will entertain this request from claims x-ray application. So here we will type the credentials of one of the users of our organization. And click sign in. So here you can see we are signed in. This user is signed in. Okay, now let's analyze the output. So here you can see authentication method. We used forms authentication, forms based authentication. You can see the UPN of the user who tried to access this application. Inside corporate network, true means this user is trying to access this application from internal network. This is the name of the user, the domain name, domain/username. This is the UPN, the claim that is issued. This is the user IP address from which machine he accessed this application. And this is the same client IP. This is the endpoint. Now, as I said, this is a web-based application. So if you remember, web-based applications communicate with ADFS server on ADFS/LS endpoint. If it is a rich client application, that will interact on MEX endpoint, which is for exchange metadata. Now, next you will see token validity. This is the access token. Access token life is for 1 hour. Access token is valid for 1 hour. Here you can see this token was issued on this date and this time, 5/27, and this is going to expire on the same date at 6/27. Remaining validity time 0 days, 0 hours, 59 minutes, 59 seconds. So access token is valid for 1 hour. Next, you will see your token signing certificate. This is the thumbprint of the token signing certificate. If you want to verify, you can go to ADFS Management Console, go to Certificates, go to Token Signing Certificate, go to Details, Thumbprint, starts with 8B, ends with AD. Starts with 8B, ends with AD. So this is your token signing certificate. Let me close this. Next is token. This is the token that is issued by ADFS server to this particular application. And the type of this token is SAML 1.0. Now let's analyze this authentication process using Fiddler. Let me start Fiddler and let's go back to the application. Test authentication. Okay, so Fiddler is capturing the logs. Okay, so I'm logged in. Let me pause Fiddler. Now let's analyze this Fiddler log. So what we did, we went to adfshelp.microsoft.com. We entered adfs.office365concepts.com as a federation service name in ADFS help, the claims X-ray tool. We selected forms-based authentication. We requested WS Federation and we selected force fresh authentication option. Here you can see we entered the federation name, federation service name. We used forms-based authentication. We requested WS Fed protocol request, and we selected fresh authentication so that we can see in Fiddler. Then I was redirected to ADFS server. Now, if you go to next header, this is the ADFS redirection page, adfs.office365concepts.com, and this is the endpoint that you can see here, adfs/ls, where this application was interacting. On this particular screen, you can see the WS Federation protocol properties. WA, WT realm, WFresh, and WAuth. These properties belong to WS Federation protocol. We will be discussing WS-Fed, SAML, and OAuth protocols in detail in one of the next videos. And here you can see the username and password of the user as well. Now let's see what token was issued by ADFS server to Claims X-ray tool. If you go to adfshelp.microsoft.com header, that is for Claims X-ray token response, under W result, you will see a token. Copy this value and go to Notepad. Paste it and save this file. Let's say token.xml. Close this. Let's go to desktop. Open this. So this is the token that was issued by ADFS server to Claims X-ray application. Now what we can see within this token, first thing you will see the time it was created. It was created on this date and this time. Then you will see expire date, what time this token is going to expire. That is 1 hour. Again, this is access token. So access token is valid for 1 hour. Next, you will see the issuer who has issued this token. This is the Federation Service Identifier name of my ADFS server. You can verify this from here. Right click on ADFS, Federation Service Properties, and this is Federation Service Identifier. adfs.office365concepts.com/adfs/services/trust. And same thing we can see here, adfs.office365.com/adfs/services/trust. Next, you will see who is going to consume this token. This token is issued to Claims X-ray tool. Next, you will see the claims, what claims are sent, UPN, primary, group SID, primary SID, name, Windows account name, group SID. These are the claims, those were sent to Claims X-ray application within this security token. And next, you will see this certificate. This is the token signing certificate that you can see. Let me copy this value. Go to Notepad, paste it, and let me remove this part. Save it with, let's say, certificate.cer. Close this, go to desktop, open this certificate, go to details. So this thumbprint starts with 8B, ends with AD. That is the token signing certificate of my ADFS server. Let's verify. Details, thumbprint, 8B, ends with AD. So this is what you can see within the security token. Now, when user is authenticated, what happens after that? In front end, we can see when user is authenticated, he gets access to the application. But in the back end, there are few cookies, those are issued to that particular user when user is authenticated. So there are 4 cookies, those are issued to the user. One is MSIS auth, second is MSIS authenticated, third is MSIS loop detection cookie, and fourth cookie is MSIS sign out cookie. Here you can see 1, 2, 3, and 4. Now what are these cookies? MSIS auth cookie is, this cookie tells that the user is authenticated. MSIS authenticated cookie will show you the date and time when this user was authenticated. We cannot convert MSIS auth cookie, but we can convert these 3 cookies. I'll show you. Right click on the cookie, then go to send to text wizard. And here you will remove these values. We only need the cookie and convert this to, let's try from base 64. So here you can see this user was authenticated on this date at this time. So this is MSIS authenticated cookie that tells you the date and time when this user was authenticated. MSIS loop detection cookie is, it tells you, it shows the date and time of the login, and it shows you how many login attempts user has made to log into that application. If you will convert this, I should see only one attempt because I was logged in one attempt. So let's delete this. And here you can see date and time, and you can see 1. That means I made only one attempt to log into this application. If I would have entered incorrect password 2 times and third time I was logged in, then you will see number 3 here. That means user has made 3 attempts to log into this application. So that is MSIS loop detection cookie. And fourth cookie is MSIS sign out cookie. What this cookie does, when user closes the browser or he logs out, so this cookie removes the user information from the browser. You can also convert this cookie as well. Same way, we will remove these unwanted values, this as well. And here you can see sign out cleanup. That means when user will sign out or he will close the browser, this cookie will clean up all the information of that particular user from the browser. So these four cookies are issued to the client or the user or the client machine when user is authenticated to a particular application. So, so if you are watching this series from the beginning, we know if there is a relying party trust, an application can communicate with ADFS server. Because without a relying party trust, ADFS server will not entertain the request that is coming from an application. We have also discussed about endpoints. In ADFS server, there are few endpoints. Those are responsible to receive certain requests from the applications. We analyzed a security token that includes claims, name of the token issuer, and token signing certificate that is used by ADFS server to sign the security tokens. And the public key of the same token signing certificate is used by the application to validate this security token. Now, if we deep dive into ADFS, we can come across multiple questions, like how an application knows that an ADFS server can issue these many claims. Or let's say email address. Let's say an application is designed in a way that it needs only email address attribute of a user when this user is authenticated. So how this application would know that this ADFS server can issue email address attribute as a claim? Or how an application can trust the issuer name that is mentioned within the security token? How an application can use the public key of the token signing certificate of your ADFS server to validate the security token. And finally, how an application would know that to which endpoint of the ADFS server I will have to reach. And the answer is federation metadata. When an application vendor wants to integrate their application with your ADFS server, they need certain information. For example, public key of the token signing certificate of your ADFS server that will be used by the application to validate the token issued by ADFS server. Then application needs the claim description so that it can ask ADFS server to include a particular claim within the security token that will be issued to this application. And finally, it would need a list of endpoints of the ADFS server where this application will connect. And all this information is available within federation metadata of your ADFS server. Federation metadata is an endpoint of your ADFS server. And to access endpoints, you can run get-adfs endpoint, and we will look for a particular property of endpoints that is full URL. So this command will list all of the endpoints of your ADFS server. And the endpoint that ends with federation metadata.xml is the federation metadata of your ADFS server. To access this endpoint, you just need to copy this and then go to browser and paste it here. Press enter. Now this will download an XML file. Open this file, and here you can see the federation identifier name or federation service identifier name for your ADFS server. For this particular ADFS server, it is http://adfs.office365concepts.com/adfs/services/trust. If you want to verify this, you can right click on ADFS, then go to edit federation service properties. And here you can see federation service identifier is set to the same value that we can see within this XML file. Next, you will see the list of claims that this ADFS server can issue to the applications. You can see here email address, given name, UPN, that is user principal name. Then you have authentication method, and you can see all the claims here. And next you will see the endpoints. You can see the endpoints here. This is the list of endpoints that this ADFS server has and where applications can interact with this ADFS server. And next you will see the token signing certificate of your ADFS server. You can find the token signing certificate in X509 certificate header. You just need to copy this value, copy this, go to Notepad, paste it here, and save this with .cer extension. Let's go to desktop and let's check this certificate. So the thumbprint of this certificate starts with 8B and ends with a D. And same you can verify from certificates, token signing certificate details. So the thumbprint of token signing certificate starts with 8B, ends with AD. So whenever an application vendor wants to integrate their application with your ADFS server, they will ask you for certain information of your ADFS server. They will ask you for the federation metadata of your ADFS server. So same way you will go to PowerShell, you will copy this federation metadata endpoint, you will paste this in browser, it will download an XML file. You just need to give this federation metadata XML file to the application vendor. They will use this XML file to get the information of your ADFS server so that the application can communicate with your ADFS server. Now let's understand what is claims provider trust. If we go by definition, claims provider trust is a medium that is used by the ADFS server to communicate with Active Directory to get the claims. Let's consider one example and things will be more clear. Let's assume we have integrated one application with ADFS server. This application has federation metadata of the ADFS server, and ADFS server has a relying party trust created for this application. Now this application knows that if any user from this organization will ask for an access, I will have to reach this particular ADFS server. And ADFS server knows that for any request coming from this application, I will have to issue a security token including the claims. And to get claims, ADFS reaches Active Directory. ADFS asks Active Directory to authenticate the user and in return issue a particular claim. And the medium that is used by the ADFS server to reach Active Directory or any claims provider is called Claims Provider Trust. To access Claims Provider Trust within your ADFS server, you will click on Claims Provider Trust. This will list all of the claims provider trust, those are available within your ADFS server. If you have Active Directory and ADFS server in your environment, then you will see Active Directory as claims provider trust. Now let's say if you want to add another provider as a claims provider trust or as a claims provider, you need to create a claims provider trust for that. And to create claims provider trust, you will click on add claims provider trust. So when you will click on this, it will ask you for certain information. If you have a file or online URL for the information for the claims provider, you can select the first option and then you can type the URL for that particular information. If you do not have online URL or you don't have that information on the local network, then you can use an XML file. We have one XML file and that is this one. So let's say somebody has provided you this XML file. You will select this option that says import data about the claims provider from a file. So browse to the file, select it, click next and give it a name, then click next. And basis of the information that is available within the XML file, this claims provider trust will be created. Now let's say you do not have the online URL and you do not have the XML file as well. Now you are left with the third option, that is enter claims provider trust data manually. Now you need to enter that information manually. So here you can type the display name for this claims provider trust, then click next. Here it will ask you for the federation identifier name of your ADFS server. For example, adfs.com. Next, this will be the identifier for the claims provider. For example, claimsprovider.com. Click next. Here you need to add the token signing certificate. Click next, and then you can review the information and then click next and click close. So this will create a claims provider trust. Now let's say you have the XML file. Let me delete this. Let's try to create claims provider trust with XML file. So you will select the second option, click browse, look for the Federation metadata XML file, click next, give it a name, next. Now here you can see, based on the information that is available within the XML file, this claim provider trust is going to be created. The token signing certificate is already there because it is available within the XML file. You can see the endpoints as well because all this information is available within the XML file. So click next and close. So a claims provider trust is created. However, when you create claims provider trust, you need to create claim rules. Because when a user will try to access an application, ADFS will ask Active Directory or the claim provider to authenticate the user and issue a certain claims to ADFS server so that ADFS server can construct a token including that claim and it can send that token to the application. So for this purpose, we need to create a claim rule. And for that, you will click on Edit Claim Rules. And here you will click on Add Rule. Under Claim Rule Template, we will select Send LDAP Attributes as Claims. Click Next. Give it a name, Test Rule. Under Attribute Store, we will select Active Directory. And then we will select an attribute or claim basis on your requirement, let's say email address. So LDAP attribute is for this particular claim, ADFS will query Active Directory that once user is authenticated, I need email address of that particular user. Outgoing claim type is when user is authenticated, what claim Active Directory is going to issue to ADFS server. So we will select that particular attribute here or the claim here. Let's say email address, then click finish, click apply and click OK. So now we have claim provider trust created and we have a claim rule created as well. So now ADFS can ask this claim provider to issue claims once user is authenticated. In ADFS server, you will find 3 certificates: Service Communication Certificate, Token Decrypting Certificate, and Token Signing Certificate. Service Communication Certificate is used for a secured communication between the ADFS server and the application. When you deploy ADFS server, you use SSL certificate that is issued by a third-party certification authority. You can use certificate from internal certification authority as well, but for production environment, only SSL certificate from third party certification authority is recommended. Now, the same SSL certificate is used to secure the communication between the ADFS and the application. And the same service communication certificate is used to secure the endpoints. Let's run get-ADFS endpoint and let's look for endpoints. And then I'll show you the certificate that is binded with this endpoint. Let's go to browser, paste the endpoint and go to certificate. So here under details, the thumbprint of this certificate starts with ED, ends with 97. Now let's go to service communication certificate, go to details and go to thumbprint, starts with ED, ends with 97. So the service communication certificate is used to secure the endpoints because whenever an application will communicate with your ADFS server, it will reach to a particular endpoint and that endpoint has to be secured for a secured communication between the ADFS and the application. The next certificate is token signing. Token signing certificate contains private keys and public keys. When ADFS server issues a token to the application, it uses the private key of the token signing certificate to digitally sign the token. And when application will receive the token from ADFS server, it will use the public key of the token signing certificate to validate the token, so that the application can trust, it can ensure that the token has been issued by a trusted issuer. Token decrypting certificate is used by the claim provider to encrypt the token using the public key of the token decrypting certificate, and ADFS uses the private key of token decrypting certificate to validate the token or to decrypt the token. Token signing and token decrypting, both certificates are valid for 1 year. If you go to details, and here you can see valid from and valid to. So by default, these two certificates are valid for 1 year. If you want to increase the validity of the certificates, you can run set-ADFS properties and you can increase the validity of the certificate. So every 1 year, either you will have to renew these two certificates manually or these certificates will be renewed automatically. Service communication certificate will not be renewed automatically. Whenever service communication certificate is going to expire, you need to renew it manually. Now, token signing and token decrypting certificates are renewed automatically with the help of auto certificate rollover feature. If you go to PowerShell and let's run get-ADFS properties and look for auto certificate rollover. By default, auto certificate rollover property is set to true. That means if it is set to true, that means the token signing and token decrypting certificates will be renewed automatically every 1 year or as per the validity of the certificate. If this value is set to false, in that case, these two certificates will not be renewed automatically and an admin will have to renew these two certificates manually. First, let's understand auto certificate rollover properties, and after that I'll show you how you can manually renew these certificates. So if you run get-ADFS properties and if you look for certificate attribute, you will see all these properties. All these properties are involved to renew token signing and token decrypting certificate. I'm going to discuss all these properties one by one. As we discussed, auto certificate rollover value is set to true by default. That means token signing and token decrypting certificates will be renewed automatically. And if this value is set to false, in that case, you will have to renew these two certificates manually. The next property is certificate duration. Certificate duration defines the validity of the certificate. By default, this value is set to 365 days, that is 1 year. If you want to change this value, you can run set-ADFS properties-certificate duration, and you can increase the validity of the certificate. Next property is certificate generation threshold. This value defines the number of days before the expiration date of the current certificate that ADFS should generate the new certificate. For example, if this value is set to 10, that means ADFS will automatically generate a new certificate before 10 days of the current certificate expiration date. Next is certificate promotion threshold. When ADFS generates the new certificates, they are initially set as secondary certificates. ADFS uses the value of this property to determine after how many days of generating the new certificate it should be promoted as a primary certificate. Then next value is certificate critical threshold. By any chance, if new certificate was not promoted to the primary certificate as per the value defined in certificate promotion threshold, then before how many days of current certificate expiration, new certificate should be promoted to primary certificate. That is defined by certificate critical threshold value. Next property is certificate rollover interval. This value is in minutes. If this value is set to 20 minutes, then every 20 minutes a check will run on ADFS server that if certificates are going to expire or not. And certificate sharing container shows the location where the token signing and token decrypting certificates are stored. If you want to modify any one of these properties, you can use set-ADFS property command in PowerShell. Now let's assume auto certificate rollover value is set to false. So in that case, you will have to renew token signing and token decrypting certificates manually. So now let me show you how you can renew these two certificates manually. Before you renew token signing or token decrypting certificate manually, you need to set auto certificate rollover property to false. If you will try to create or add a token signing or token decrypting certificate, you will get an error. It says certificates cannot be modified while the ADFS automatic certificate rollover feature is enabled. Disable the feature using the PowerShell command and then try again. So let's disable this property first. Set-ADFS properties -auto certificate rollover and $false. Let's verify, and this value is set to false. Let's go to ADFS management console and first let's try to renew token signing certificate. You will click on add token signing certificate, and here you will select a token signing certificate. You can browse the certificate as well and then click OK. Now this certificate will be added as secondary certificate. Click OK. So the new certificate is added as secondary certificate. That means ADFS server will not use this certificate as of now to sign the tokens. Now, if you want to force ADFS to use this certificate, the new certificate to sign the token, in that case, you will have to set this certificate as primary certificate. So you will select this and then you will click set as primary. Click yes. And now this certificate is set to primary certificate. That means now onwards, ADFS will start using token signing certificate, this new certificate to sign the security tokens. Same way, if you want to renew token decrypting certificate, you will click Add Token Decrypting Certificate, then select the certificate, click OK, and again, new certificate will be added as secondary certificate. So same way, you will have to set this certificate as primary. And once you have renewed token signing and token decrypting certificates, you can enable auto certificate rollover property. Set-ADFS properties, auto certificate rollover, $true. Press enter. Let's verify. And this value is set to true. So again, if auto certificate rollover is set to true, you don't have to renew token signing and token decrypting certificates manually. Auto certificate rollover property will renew the certificates automatically as per the properties defined that we discussed. If you run certificate, this one, based on the values of these properties, auto certificate rollover will run a check on ADFS server that whether these two certificates are going to expire or not. And then based on these values, it will generate a new certificate and then it will automatically promote that certificate as primary certificate. So now let's recap what we have covered in this particular session. Service Communication Certificate is used for secure communication between the application and the ADFS server. This certificate is used to secure the endpoints. For production environment, you should always use an SSL certificate that is issued by third-party certification provider. But if you are deploying a test environment, then you can use certificate that is issued by internal certification authority. The subject name of the certificate must match the Federation Service identifier of your ADFS server. You can use either wildcard certificate or a SAN certificate. Both type of certificates are supported. And same certificate can be used on all the ADFS servers and proxy servers. Token signing certificate is used to digitally sign the tokens. Those are issued by the ADFS server to the application. And token signing certificate is created by default as a self-signed certificate. But you can also use certificate issued by third party or from internal certification authority. Token decrypting certificate is used by the claim provider to encrypt the token using its public key, and ADFS uses the private key of this certificate to decrypt the token. And token decrypting certificate is created as a self-signed certificate by default. In this example, we have two organizations, ABC organization and XYZ organization. ABC organization has a federation trust set up with XYZ organization, and application of XYZ organization is added as a relying party trust in ABC organization. So the ADFS server of ABC organization has a relying party trust for this particular application. A user from ABC organization is trying to access an application that is hosted in XYZ organization. When this request will go to the application will ask the user to reach the federation server of XYZ organization because the application can't authenticate the user. In third step, client will go to ADFS server of XYZ organization and will ask for permission to access the application. ADFS server of XYZ organization will identify that this user doesn't belong to XYZ organization. So this server will perform home realm discovery to find out to which organization this user belongs to. And it will present the user with a web page to choose his organization name. For example, in this picture, if the user belongs to Contoso organization, User will click his organization name and he will be redirected to his organization's ADFS server. This is called home realm discovery. In the fifth step, user will select his organization from the web page. He will enter his credentials and will be redirected to his organization's ADFS server. Then ADFS server will contact domain controller to validate the user. Domain controller will authenticate the user using integrated Windows authentication. And once domain controller will validate the user, ADFS will construct a token. It will sign the token using private key of the token signing certificate and will send that token to the client. Then client will post this token to the ADFS server of XYZ organization. Then ADFS server of XYZ organization will use the public key of the token signing certificate to validate the token. If it finds the token is valid, it will create a new token and will share this token to the client. Client will pass this token to the application and web application will grant access to the user. So this is how authentication flow works in ADFS. Now let's understand what is passive authentication in ADFS and how does it work. When a user tries to access a federated web application, that is called passive authentication. And this type of request is handled by ADFS/LS endpoint. In this example, a user is trying to access outlook.office.com or OWA. Evo STS is the STS point or the security token service for Office 365. And IDP is the ADFS server of the organization that this user belongs to. So let's see how this user will be authenticated. User will enter outlook.office.com in browser. Then user will be redirected to Evo STS, that is login.microsoftonline.com. Then user will connect to Evo STS. Evo STS will present Office 365 sign-in page to the user, and user will enter his user principal name. Evo STS will check if the domain of the user is federated or not. So it will return the STS endpoint to the user. That means the user will be redirected to his ADFS server. Then user will contact its STS endpoint, that is the ADFS server of its organization. ADFS server will present forms-based authentication prompt to the user. Then user will enter his password. When user is authenticated, ADFS server will issue a token to the client. Client will post that token to Evo STS. Evo STS will issue authentication cookies to the user and user will get access to OWA. So this is how passive authentication works in ADFS. Now let me demonstrate you practically how this authentication works and how to analyze this authentication flow using Fiddler. So let's log into outlook.office.com and let's log in with the user whose domain is federated. So now this user is redirected to ADFS server. Let's type the password and this user is logged in. Now let's go to Fiddler and let's analyze these logs. So here what we can see, we typed outlook.office.com, that is OWA. We were redirected to the STS page for Office 365, that is login.microsoftonline.com. On STS page, I entered user principal name for the user. Then I was redirected to the ADFS server. This is the user principal name of the user who was trying to log in. After that, here we can see the password of the user as well. And when this user was authenticated, few cookies were issued to the client machine. These 4 cookies were issued. MSIS auth cookie defines that the user is authenticated. MSIS authenticated cookie tells you the date and time when this user was authenticated. If you want to convert this cookie, right click on this and then go to send to text wizard. Here remove the unwanted values and let's convert it with from base 64. So here you can see the date and time when this particular user was authenticated. The third cookie is MSIS loop detection cookie. This cookie tells you how many attempts user has made to log into that particular application. You can convert this cookie as well. Same way, delete unwanted values. And here we can see one attempt. That means user has made only one attempt to log in to portal.office.com or to Office 365 application. And the fourth cookie is MSIS sign out cookie. What this cookie does, when user clicks sign out or if he closes the browser, it simply removes the user information from the browser. This is sign out cleanup cookie. You can convert these 3 cookies, but we cannot convert MSIS auth cookie. Apart from that, when this user was authenticated, a token was issued. If you want to check this token, you can copy this and go to Notepad and save this as XML file. Let's close this and go to desktop. Let's open this. So this is the security token that was issued by the ADFS server to Office 365. So this is the access token. Here you will see the date and time when this token was created, 1st of January 2022, and this time. Date of expiration of this token, which is valid for 1 hour. Next, you will see the name of the application who is going to consume this token. And then you will see the name of the issuer, the Federation Service identifier name of your ADFS server who has issued this particular security token. Next, you will see the user principal name and immutable ID. In case of Office 365, only 2 claims are issued within the security token: user principal name and immutable ID. This is the user principal name of the user who was trying to access outlook.office.com, and this is the immutable ID of this particular user. Next, you will see the token signing certificate. If you want to check this certificate, you can simply copy this value till here. Go to Notepad. Let me remove this and save this value. And save this with .cer extension. Enter. And let's go to certificate. Go to details. The thumbprint of this certificate starts with ED, ends with 97. Now let's go to token signing certificate. And the thumbprint of this certificate starts with ED, ends with 97. So these values are issued within the security token, and this is how you can analyze the entire flow using Fiddler logs. When we install ADFS server, we do not expose it to the internet. That means this ADFS server always sit behind the firewall. And the reason is, if we expose our ADFS server to the internet, then anyone from the external network can access this ADFS server and can get access to the internal network. And this is going to be a big threat to the organization's security. So this is the reason we always install ADFS server within internal network. But what if an external user wants to access an application that is integrated with ADFS? Or let's say a user from the same organization is trying to access an application from the external network. So how these requests will be handled by the ADFS server? And the answer is ADFS proxy server. ADFS proxy server is also called Federation proxy server, remote access role, or web application proxy server. ADFS proxy server is always deployed on perimeter network or DMZ network. This network is not part of the same network segment that ADFS server is using. The purpose of ADFS proxy server is to receive and forward the request to the ADFS server. ADFS proxy server doesn't issue a token. Its function is just to listen to the external request and forward those requests to the ADFS server. Then ADFS server contacts Active Directory for the authentication and it issues the token to the client machine. If you go to ADFS Server Management Console and if you navigate to endpoints, you will see proxy-enabled properties for all the endpoints. If this property is set to true, that means these endpoints are enabled on the ADFS proxy server. So if any external request is coming from the web browser, that request will be received by the ADFS proxy server and will be forwarded to the ADFS server. So this is what ADFS proxy server does. Few important points that you should be aware of about ADFS proxy server are: it reduces the security risk to the ADFS server. You do not have to expose your ADFS server to the internet. ADFS proxy server doesn't issue tokens. ADFS proxy server doesn't authenticate the users. ADFS proxy server is always deployed on the perimeter network. The role of ADFS proxy server is to receive external requests and to forward those requests to the ADFS server. It helps ADFS server to identify which request is coming from the internal network and which request is coming from the external network. And by deploying ADFS proxy server, we can enable MFA for external users. Now let's talk about the prerequisites that need to be met before we deploy ADFS proxy server. You can install ADFS proxy service on Windows Server 2012, 2012 R2, 2016 and 2019. Port 443 should be opened between ADFS server and the machine on which you are going to install ADFS proxy service. You need an SSL certificate to install ADFS proxy service. You can use the same SSL certificate that you are already using on the ADFS servers. ADFS server should be reachable from the machine on which you are planning to deploy ADFS proxy service. And you would require local administrator credentials of the server. So first, let me show you how to export the SSL certificate from the ADFS server, and then we will use the same certificate for the installation of ADFS proxy server. We will go to Service Communication Certificate on the ADFS server, go to Details, and click Copy to File. Click Next. Click Yes, export the private key. Next, click Next, and here type a password, click Next, and here you can browse to the location where you want to save this certificate. And I'm going to save this on desktop with ADFS proxy cert name. Click Save, Next, Finish. Click OK and close this window. Now what we need to do, we will copy this certificate and we will paste this certificate on the server where we want to deploy ADFS proxy server role. So this is the server where I'm going to deploy ADFS proxy role. Let me paste this certificate on this particular server. And this machine is not a domain joint machine. It's a work group. And this is Windows Server 2016 data center. I'm going to install ADFS proxy role on this particular server. So once you have pasted this certificate, double click on the certificate, select local machine, click next, click next. Here, type the password, next, and automatically select the certificate store based on the type of certificate. Click next, finish. That's it. Now we can use this certificate for the installation of ADFS proxy role. Now the next thing that you need to check is whether this machine can reach the ADFS server. And for that we will go to command prompt and ping the fully qualified domain name or the FQDN of the ADFS server. For my case, it is adfs.office365concepts.com. This machine will not be able to reach to my ADFS server because this machine is not a domain joint machine. Now, how we are going to achieve this? We will make an entry within the host file. If you want to access the host file, you can go to the C drive, then go to Windows, System 32, Drivers, etc. And here is the host file. Open this file with Notepad. You can use WordPad or Word as well. And within the host file, we will make an entry. And that will be the IP address of the ADFS server, and then the fully qualified domain name or the FQDN of the ADFS machine. That is adfs.office365concepts.com. Save this file, close this as well, and let's try to ping it again. So now you can see this machine can reach the ADFS server. Make sure you are pinging the FQDN, not the IP address of the ADFS server. This machine should reach the FQDN of the ADFS server. Only then you will be able to install ADFS proxy role on this particular server. Else, while installation, you will come across an error. So now we have met the prerequisites. We have this certificate that we can use for the installation, and this server can reach the ADFS server as well. So now we are good to go and we can install the ADFS proxy role on this particular server. We will go to Server Manager, click Add Roles and Features, click Next, Next, click Next. Here we will select Remote Access because this is the role for the Web Application Proxy or the ADFS proxy. Click Next. No changes required here. Next, Next. Here we will select Web Application Proxy and then we will click Add Features. Click Next and click Install. So this will install the Web Application Proxy role on this particular server. And once this role is installed, after that we will configure this server as ADFS proxy server. So let's wait for a couple of minutes, and once it is completed, then we will configure this server. So this role is installed now, and to configure this server as a web application proxy or ADFS proxy, we will click on this link, open the web application proxy wizard. Click on this and this will open another wizard. Click on next. Now here we will type the federation service name of your ADFS server. For my case, it is adfs.office365concepts.com. And these are the credentials of the local administrator of this particular server. Click Next. Here we will select the certificate, click Next, and click Configure. So the web application proxy has been configured successfully. Click Close. And now this will automatically open Remote Access Management Console from where you can manage your proxy server. I already have one relying party trust created for portal.office.com. So this particular relying party trust is already configured on this particular web application proxy server or on ADFS proxy server. If in case the relying party trust is not configured automatically, you can configure it manually as well. You can click on publish. Now, what exactly it does, if you have a relying party trust, let's say you have a relying party for Office 365. When external user will try to access Office 365 application or portal.office.com from external network, that request will go to your ADFS proxy server, not to ADFS server. So the proxy server should have the relying party trust published on this particular server so that the users from the external network can reach to those applications. So to publish a particular relying party trust on proxy server, you will click on publish, click next, click pass through, next, and here you will type a name, for example, test application. External URL will be the reachable URL, the external URL for the application. For example, login.microsoftonline.com. Then you need to select the certificate that will be used for the communication, and then you can click next and click publish. This particular relying party trust will be published on this particular server. So this is how you can configure the ADFS proxy server. If you want to check the status of the proxy server, you can go to operation status, and here you can see ADFS proxy is working, web application proxy working, ADFS proxy working, web application proxy core is working. So ADFS proxy server is working properly.